Sixth grade into math lesson 2.2, represent division with two-digit divisors. I can find the quotient of numbers up to 4 digits divided by two-digit divisors using a visual model. Spark your learning. You are a game designer designing a treasure hunt game similar to the one shown. The game board is a grid with a treasure chest located behind one of the squares. The rectangular grid will have 96 squares. If the length of the grid is greater than 10 squares, how wide can the grid be? Okay, so we have 96, and then the length of the grid has to be greater than 10 squares. How wide can the grid be? Okay, so what is an easy multiple? Okay, what is 96 an easy multiple of? What would be a good factor of 96 that you know right off the top of your head? Is 12 one? Okay, and is that greater than 10? Yes. Okay, so we're going to draw out 12 boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we did 12 boxes out. Okay, what is 12 times what is 96? 8, right? Okay, so we'll go 8 boxes down. So 1, 2, 3, 4, 5, 6, 7, 8, and then it'll come across and make our box. Oh, well, a little better than that than what mine looks like. Okay, so technically we should have how many boxes there? 96, right? So the game board grid can be how many squares wide? So 8, right? Okay. Build understanding number 1. You are designing another game in which the players need to arrange flower pots in 12 equal sized groups. There are 156 flower pots. How many flower pots are in each group? So there's 12 equal sized groups, 156 flower pots. How many flower pots are in each group? What multiplication and division equations can you write to model the number of flower pots? And they're labeling the flower pots in this situation as P in each group. So our multiplication one would be what? 12 times P equals 156. What would our division problem be? Or let's do 156 divided by 12 equals P for the number of flower pots. Okay, so same thing, basically we just put it in a little different order. Letter B, how can you break apart 156 into a sum of multiples of 12? Use your multiples to make an area model. So we know that 156, so and then 12. So like I said, they wanted us to go ahead and break that apart. Okay, so we can go down 12, right? Okay, so if we go down 12, we're going down all the way except for 1, right? Okay, now what are some, so 156, remember yesterday we broke those into pieces, into chunks, okay? So what can we do? Can we do 60? Okay, so we could do 60. Can we do another 60? Yeah. Can I do another 60? No, I'm left with what then? 36. So 60 plus 60 is 120. And then 156 minus 120 is 36. Okay, so what times 12 gets me 60? 5. So I can do 1, 2, 3, 4, 5. Oh, I cut it off too short. Okay, so 5. Whoops. And then will you do another section of 5, right? Okay, and then how many? What's 36 divided by 12? 3, right? So 3 more sections, right? Okay, so then I'm going to do what? Add those, right? Okay, so 5 plus 5 plus 3 is 13. Okay, so we have a total of 13 columns, right? So our 12 was over here, and we have a total of 13 columns. So how is the dividend represented in the area model? So that was what? How many rows we had, right? Okay, and then our quotient got us how many columns we had, right? Okay, so how many flower pots are in each group? So 13 flower pots. There are 675 gold bars hidden throughout the game. The same number of bars are placed in each of the 25 treasure chests. How many bars are in each treasure chest? So 675 golden bars, 25 treasure chests. How many bars are in each chest? Okay, remember, please circle our information and underline what we're looking for. So what division equation models the situation? So what are we going to write? 675 to what? Divided by 25 equals B. We'll put B for the number of bars. Okay? So break apart the dividend into multiples of the divisor and use the area model to find the quotient. So basically, we're going to do kind of like we had yesterday. We're going to have our bar. We're going to have 25 out here. What are some good units 25 can go into that we easily know? Well, like what about like units, guys? Like 100, 200. Can we go ahead and just do 300? Yeah. How many quarters would be in $3? There's 4 quarters in $1. So 4 times 3 is 12. So we can put 12 here. So I have 300 here. Do I need another 300? And then what would I have left? 75. So how many quarters would be in the other 300? 12, right? And then how many quarters would it take to have 75 cents? 3. Okay, so explain what the smaller rectangles represent in terms of the division equation. So when we broke the rectangle into smaller pieces, that represents the partial product of what can get us to 675, right? Or the add-in. Okay, so how many gold how many gold bars are in each treasure chest? 27. So 12 plus 12 is, plus 3 is, so 27 gold bars. Well, understanding numbers, archaeologists find a sunken chest of 3,420 bronze coins. If the coins are to be shared equally among 20 museums, how many coins does each museum get? How can you model this situation using a division equation? So we have 3,420 bronze coins, 20 museums. How many coins does each museum get? So what's my equation going to be? 3,420 divided by 20 equals C, right? For the coin. Don't forget to circle and underline. Circle your information, underline what you're looking for. Draw an area model to find the quotient. How can using a greater multiple of the divisor help you draw the area model? So we're going to use 20, right? Okay, what can I use here? Well, we could use 100, but if we use 100, are we going to be doing it for a long time? So instead of 100, could we use 1,000? Okay, so I could do 1,000. I could do another what? 1,000. Do I need another one? Okay, then I would have what? Can I do 400? Okay, and then I can do 20. Okay, so if I do this, I have a 0 here already, right? So I can mark off a 0 here, right? So how many times, and then basically we would pretend like we marked off the 0 and the 20, right? So how many times does 2 go into 100? 50 times, right? Because 50 times 2 is 100. So each one of these would be 50, correct? Okay. Once again, do I have a 0 in my dividend and a 0 in my divisor? Yep. So I can mark this off. So 2 into 40, 20 times. And then 20 into 20 would be 1 time. So then I come across and I add all these up. So 50 plus 50 plus 50 is 150 plus 20 is 170 plus 1 is. Okay, so how many coins does each museum get? 171 bronze coins. And then how does our area model show this? So basically we just broke apart 3,420 into smaller pieces, divided it by 20, and then put those pieces together, right? Okay. Check understanding number 1. There are 76 bottles of paint in the art studio. The art teacher divides them equally among all 19 students in the class. How many bottles of paint does each student get? So 76 bottles, 19 students. How many bottles of paint does each student get? So we're going to have our bar model. What are we dividing by? 19. Okay, what's a good unit of 19? Can we take it times 2? Okay, what is 19 times 2? 38. Can I do another 38? Yeah. Can I do anything else? Nope. So 19 goes into 38 how many times? Twice. Add it together and get, so 4 bottles. On your own, number 2, model with mathematics. Lucinda has 81 tulip bulbs. She plants 3 bulbs in each row. How many rows of tulip bulbs does she plant? Write a division equation to model this situation. Okay, so basically we're going to take what? 81 bulbs divided by 3, right? And then how many rows? So 81 divided by 3 equals our answer. So I'm going to have my box. And I'm going to put 3 out here. What would be a good unit of 3? 30. You guys agree? Okay. So we could do 30. Can I do 30 again? Can I do 30 again? No. So I'm up to 60. So what's 81 minus 60? 21, right? Okay. How many times does 3 go into 30? 10 times. So do that twice. 3 into 21? 7. And then I'm going to add these together and get 27. So 27 tulip bulbs. Number 3, model with mathematics. Write a division equation that is related to the application of the distributed property shown. Okay, so basically, what is our total? 1,488 divided by, okay, so basically, what's our division? What are we dividing by? What do you see as a constant thing throughout that top? 12, right? Equals, and then if we would add what? 100 plus 20 plus 4, we would get what? 120.